Okay, so in the second problem, we have a pendulum connected to some platform up here, and it is connected by a horizontal string to something else, probably a wall. It doesn't matter. Okay, in part A, what they want us to do is draw a free body diagram showing and labeling the forces that are acting on the bob. So if you see bob, that just means the thing attached to the string in a pendulum. Okay, so looking up at this diagram, the forces acting on this object right here are the tension from the platform it's hanging from, the tension in the string between the bob and the wall, and of course gravity. So we have Fg pointing straight down. We have tension 1, or the horizontal tension, okay, and a second tension, and we had to know that this angle right here is 30 degrees. Okay, so these are the three forces you need to have in your force body diagram. You also need to have indicated the angle. Now, if you're wondering how we know that angle, look back up to the original picture. If we draw a straight line down that's parallel to the vertical, so parallel to the line that shows us where the bob would be if it was hanging straight down, we can make two triangles. Okay, I know that since this angle is 30, this one right here must be 60. Okay, if that angle is 60, since the angles in this triangle that I'm outlining right now must be equal to 180 total, this angle also has to be 30 degrees. Okay, so in scoring yourself on this force body diagram, give yourself 2 points total if you had the correct diagram. Okay, if you are missing one force, subtract 1 point. If you are missing more than 2 forces, you need to subtract 2 points. If you are looking at your diagram and you realize you have additional forces that I haven't drawn in here, you need to subtract a point. Or if you did not label the angle, you also have to subtract a point. Okay, so there are 2 points total for the correct, and basically you're just losing points if you've drawn any forces in incorrectly. Okay, in part B, they ask you to calculate the tension in the horizontal string. Okay, so looking at our force body diagram, they're basically asking, what is TH? Okay. Now to figure this out, we need to use our Newton's second law equations. So the sum of the forces in the x direction are equal to mass times x acceleration. Sum of the forces in the y direction are mass times y acceleration. Okay. In order to find these, we need to break TP up into horizontal and vertical components. Okay, so the horizontal component will be TP sine 30 because it is opposite, and the vertical component will be TP cosine 30 since it is adjacent to the angle that we care about. Okay, now I'm going to go ahead and basically use my picture to write my Newton's second law equations. For the horizontal direction, I have TH minus TP sine 30 is equal to 0. The reason it's 0 is that we're at equilibrium, so all of our accelerations are equal to 0. The net force is equal to 0. In the y direction, or the vertical direction, we have TP minus FG equals 0. And I need to correct myself. We have TP cosine 30 minus FG equals 0. Okay, in the end, we want to find the tension in the horizontal string. So we're looking for TH. Okay, I'm going to go ahead and find a value for TP using my vertical information. And then once I find a value for TP, I'm going to plug it into my horizontal information to solve for TH. So I have TP cosine 30 minus FG equals 0. TP cosine 30 equals FG. Since we know the mass, I guess I'm pointing to something you can't see, the mass of the bob is 1.8 kilograms. FG is 18 newtons. So TP cosine 30 is equal to 18 newtons. At this point, we just have to figure out what cosine 30 is equal to. It's something like root 3 over 2, but I'm gonna cheat and use my calculator. So cosine 30 is equal to 0.866. 18 divided by cosine 30 is about 20.78. Okay, plugging that back into our x information, we know that TH equals TP sine 30. Sine of 30 is 1/2, so TH is 20.78 times 1/2, which is roughly 10.4 newtons. Okay, so that was part B. Part B is worth a total of 4 points, okay? So this is how you're going to assign yourself points. If at any point you said that the net force was 0, or you put a 0 into your Newton's second law equation, give yourself 1 point. Okay? If at any point you tried to figure out what the components of TP were, give yourself 1 point. If you correctly figured out the components, so you went through this process and you found that this should be, the horizontal side should be TP sine 30 and the vertical side should be TP cosine 30, give yourself 1 point, and then the final answer with correct units, and some of you are forgetting your units, give yourself 1 more point for 4 points total. Okay. In part C, they're asking you to figure out the speed of the pendulum, or what the speed of the pendulum would be if a horizontal string were cut. So basically, you'd be cutting something right here, and the pendulum would be swinging down. Okay, for this you're going to use conservation of energy. Okay, so I have to make sure I'm pointing where you can see. If you're using conservation of energy, you know that all of the energy at the beginning has to equal to the sum of the energies at the end. Okay, at the beginning, so before it's cut, it's not moving, we only have gravitational potential energy. Okay, at the end, we know it is moving, and we have kinetic energy, we still have gravitational potential energy. Now, it's your choice where you want to pick height equals 0, but for most of these problems, the easiest thing to do in terms of calculations is to pick the top of your pendulum as height equals 0. Now what this means is that all of your gravitational potential energies should have negative values, because if height is 0 and your pendulum is hanging down below that height equals 0, you always are at a negative height. Okay, so back to conservation of energy. At the beginning, we know we only have UG naught, okay, and UG naught is equal to UG final plus K final. Okay, we have to do a little bit of geometry in order to find UG naught and UG, but it's really not going to be that bad. So looking back up at our original picture, okay, we know the length of the pendulum is 2.3 meters. Okay, we know that this angle right here is 30 degrees, so the initial height of the pendulum is negative. Don't forget that it's below the 0 line. 2.3 times cosine 30. Okay, at the end, we don't even have to do geometry. This is how easy it is. Our final height is just the whole length of the pendulum, but remember it's below our 0 line, so it's height negative 2.3 meters. Okay, so we're going to bring that back to our conservation of energy equation. We have kind of a blurry camera. Sorry, give me a second. We have mgh naught equals mgh plus 1/2 mv squared. Okay, since every single term has m, we're going to go ahead and get rid of that. So we have g times h naught. H naught is negative 2.3 cosine 30 equals g, I'm just crossing out on the ends, times negative 2.3 plus 1/2 v squared. And this v squared is what we're looking for at the end of the day. Okay. Now, you're going to go ahead and get your calculator ready. You know from the last part that cosine of 30 was equal to 0.86. So we have 10 times 2.3 times 0.86. Which is roughly